Hi, I'm Mariggis, and this is an overview of what I do with MATLAB. I take any regular screen and a camera or two and convert them into a touchscreen with MATLAB software. Now the screen can be any average or large screen, or it can be a projector, and then it would be like a substitution for a smartboard. A cheap one, which makes it more affordable for schools and anyone who likes a smartboard.
There are two main steps involved with implementing this. The one is to find where the pen tip is, and it is the pen tip because just like at any regular smartboard you interact with a pen. And the second is to do the appropriate mouse commands at the appropriate position on the screen. You may have noticed that in the beginning I was using a green shiny pen compared to the black that you currently see. I started off doing my experiments with such a black pen, and the fact that it appears darker compared to the screen that appears lighter on the captured frame. Detecting a green shiny pen is much easier. You just reduce the camera exposure time to very low values, and if the pen is bright enough, then it is the only thing you basically can see on the captured image, which is here on the left. You then run simply through every pixel of the image and check if the green intensity value is by a certain value larger than the blue plus the red ones, and create the corresponding logic array. I then apply an operation that tries to fill in small gaps on this array, getting the right one. A further operation on this array removes potential noise and only leaves the largest block of interconnected ones. Projecting the white points of the logic array onto the camera image shows that they represent pixels where the pen is sighted. So since all these points line the pen area, fitting a straight line through them should be going along the pen from the start till the end of it. Then, this path that you can see in red is used to create a vector which contains values for the green dominance along the line. The blue curve on the right is a plot of that vector. This function is then passed through a moving average filter to get rid of two large fluctuations. The result is plotted in red on the same graph. The filtered vector is then used to locate the tip of the pen, which is taken to be there where the red curve is starting to increase a lot. You can see the location of the detected position of the pen tip on the camera frame. It is at the intersection of the horizontal with the vertical white line. Alright. So now we have the location of the tip on the camera frames, and what we need to know is the corresponding positions on the screen. For this I use the functions like that. These relate camera frame coordinates to screen pixel coordinates. These functions are obtained by a calibration process similar to that of a normal touchboard. The user holds the pen on predefined locations on the screen, and the program relates that data for these few points. This information is then interpolated to give results for the entire screen surface. I did the interpolation using MATLAB surface fitting functions on a 3x3 surface polynomial. The next issue is to know whether the pen is actually touching the screen, or if it has a certain distance away from it but still being captured by the camera as being pointed on the screen. One way to go is to use two cameras and check if the obtained coordinates match. If they do, it's touching, and if they don't, they're not. Another way is to include a switch telling the computer if to accept that coordinates is touching or not. This could be done by controlling the LEDs on the pen, for example, or sending signals to a communication channel. A further option could be that the switch is being placed on the pen tip, acting on pressure or hand controlled. One last step I did was to implement a short moving average filter on the screen coordinates to stabilize them and get a nice cursor movement and steadiness on the spot. From the touch-no touch detection options I described, I implemented the one that uses two cameras and the one with a hand-controlled switch that is sending the touch status through a communication channel. Both were pretty fine on a 32-inch screen, although the one with the switch was easier and faster to operate. And this is how I converted that regular screen into a touchscreen with MATLAB. Now, I also wrote some code based on very similar principles to enable laser pointer cursor control on such a system. Here a little clip showing that. Thank you very much for watching this video.